Hey everybody, Mr. Murray here, Mr. Murray's Mathland, continuing on with estimating area under the curve using Riemann sums. But this time, today's example, we are looking at values that are given in a table. So you don't have an equation of the function. And this is a pretty common thing on the AP, on free response questions actually. And in multiple choice occasionally too, but almost always on a free response, one of them has this. So definitely not a difficult thing to deal with if you are familiar with it. So here's the thing. You're given only selected x values from the differentiable function f of x, differentiable, so that means it's also continuous. Using the subintervals of 0 to 1, 1 to 4, 4 to 9, and 9 to 11, let's estimate the area using these various methods. Now the one thing you can't do is with the equations, we've been doing equal width rectangles, equally spaced subintervals. And as you'll notice, 0 to 1 is not the same width as 1 to 4, or 4 to 9, or 9 to 11. So each one of these rectangles is going to have a different width, which means I have to find their areas, individually. So, for example here, my left sum of 4 rectangles, the very first, remember the difference in x, the delta x, is your base of the rectangle. So that is 1, from 0 to 1. So we have a base of 1, and the height was given to you by the y value, or the function value, at the left side of the interval. So between 0 and 1, here would be the left height, right? The left y value would be 1 times 8. That would be your area for that interval. Plus the next interval from 1 to 4 would have a base of 3. Your delta x is 3 multiplied by your height, which would be given by the left y value of the interval, which is 11, plus the next interval, which has a base of 5, multiplied by that left y value of 18. And lastly, the last interval has a base or a width of 2, multiplied by that left height, so of 30. And so, of course, we can, get these, but again, you just had to get them individually. You couldn't just factor out the base and add up all the heights. So 1 times 8 is 8, 3 times 11 is 33, 5 times 18 is 90, plus 60. To add these all up, 150 plus 41, 191. And there we go. Now, so not a difficult thing, and if you really, really need to, until you get the hang of it, you could always plot these points on a rough sketch, and just to visualize those rectangles standing up if you like. But again, once you really get the hang of it, you're just after the width of the interval multiplied by the appropriate y value to get that height. So when I now do it with 4 right rectangles, it's going to be much the same. The width of the intervals is not changing. That's still going to be 1 times, but now we're going to use the right side of the interval as the height. So 1 times 11 plus the next interval is 3 times 18. Next interval, base of 5 times a height of 30, plus last interval, base of 2, height of 36. And so we add those up, individually, so we get 11 plus 3 times 18 is 54, plus 5 times 30 is 150, 2 times 36 is 72. And we add these all up here. That's going to be 65 plus 150 plus 72. It's going to give you 287. 287. Yeah, I just got a little lazy and did it in my calculator off to the side. Don't think any less of me. Okay, so that's it. In a way, it's easier than doing it with an equation. But how about we take a look at, suppose we want to estimate this area with trapezoids. So similar deal, that the width of the intervals is not the same, so I'm going to do these with individual trapezoids. Just remember what each part represents, right? This width of 1 is the height of the trapezoid. That 3 is the height. That 5 is the height. That 2 is the height of the trapezoids. And each trapezoid, the bases are both sides of the interval, the left and the right, right? That's base 1 and base 2. So just keep that in mind when you're doing this. So the one thing you could factor out, I guess, of this is that all the trapezoids have 1/2 in the formula. So you could do 1/2 out in front of a bunch of stuff, but it's probably easier to just do it individually. That's just my opinion here, because you're still doing a lot of little individual parts. But whatever works for you. So my first trapezoid is 1/2 the height of 1. Again, that's the width of the interval. And the sum of the bases is the 8 plus 11. Plus the next interval from 1 to 4, 1/2 the height of 3 times the sum of those bases, which is 11 and 18. Plus 4 to 9, 1/2 of that height of 5. The sum of the bases, 18 plus 30. And lastly, plus 1/2 that height of 2, 30 plus 36. And then, simplify this however you like, using your calculator or whatever. So I'm actually going to do that. That's going to be 1/2 of 19 plus 1 times 1 to 9 plus okay, and we should get a grand total of 239. Okay, so trapezoid rule, still no sweat with a table, as long as you know which parts represent which. And like I said, if you really must, draw a quick sketch off to the side on scrap paper, plot the points. Doesn't even have to be to scale, but just so you can visualize those trapezoids standing up, if you like. And lastly, why not do with some midpoint rectangles. Midpoint rectangles. Now notice we're only doing 2 midpoint rectangles using the intervals 0 to 4 and 4 to 11. And here's why, of course, because if you're going from 0 to 4 as your first interval, that's a width of 4. That's the base of the rectangle. But with the midpoint, you're not using the left or the right as the height. You're using the middle value. And actually, this isn't quite appropriate, really, because 1 is not the midpoint of 0 and 4. But let's just say they gave you 2. You would be using the middle y value of the table. So my first rectangle is a width of 4 times my middle y value of 11. Yeah, I would be a little more careful if I made this problem up in the future, or the AP certainly would. But I figured I'd just tack it on to this already problem I was already doing. And this second rectangle has a width of 7, and I won't be using the left or the right. I'd be using the middle y value. And again, this is not quite correct, because 9 is not the middle x value between 4 and 11. But on a real AP or real test question, I would be a little more careful about that. And it would be 7 times 30. And there you go. You'd get 44 plus 210. So you'd get 254. Okay, so you got the general mechanics of it, barring the, slight question flaws, which are my fault. But hopefully this all makes sense, and you're comfortable seeing these things in a table. As always, if you have any questions, just ask, and we'll see you later, kids.